Hi everybody. Good evening everybody. A quick sound check. Are you able to hear me? Awesome. A few pointers before I dive into today's session. This is part 2 of a 7-part series. If you have not viewed part 1, you can find the link in the description. Also, some students asked for practice problems. So we made a playground for them to practice. Right, you can find the link of the playground also in the description. I would suggest that people who want to practice, please go ahead and solve those problems. And I also suggest that you subscribe to our channel to not miss out on future sessions like these. Now let's not waste any more time and jump into today's session, which is dynamic programming. So what is dynamic programming? Yesterday I gave a small hint about what is dynamic programming. So we were discussing Fibonacci series and we solved it using recursion. Right? So what did we say? We said fib of n is a function. Now I am going to say if n is equal to 0 or 1, or I can say n is less than 2, whichever way, I am saying return n. Otherwise, I am going to say, hey, you should return fib of n minus 1 plus fib of n minus 2. So this is something which we discussed yesterday, and we also discussed the problems with this. What was the problem with this? The problem is fairly simple. This is going to be drawn into a recursion tree. So fib of n, let's say I take fib of 5. Fib of 5 is a function which is going to call fib of 4 and fib of 3. Fib of 4 is going to call fib of 3 and fib of 2. As you can see, we are already calculating the same thing twice. Now, not only is this going to be computed, this is a recursion function, remember. So, it is going to call two more functions again and again, which means that this is going to become fib of 2 and fib of 1, and this is again going to become fib of 1 and fib of 0, and this is going to become fib of 1 and fib of 0, and this continues. The problem with this is that, right, the time complexity of this is going to be exponential. So what is the time complexity? It is 2 power n, which is exponential. I can see that there is some problem with the screen, right? So you are not able to see what I have written on the top, but I think that is fine, right? Let's keep going. The time complexity of that is exponential. Yes. Now we are going to look at how do we reduce the time complexity. So that is where dynamic programming comes to rescue. So what exactly is dynamic programming? It is fairly easy. Right? Dynamic programming is when there are sub-problems which are overlapping. As you can see, right, what is fib of 5? Now I am breaking fib of 5 into sub-problems, fib of 4 and fib of 3. And fib of 3 is overlapping, right? Because to solve fib of 4, I again need fib of 3. So I am trying to store this value, so fib of 3 value in some place, right? It could be an array, it could be anywhere. So if I store those values anywhere, then I don't need to calculate it twice, right? I will use the value from the data structure. So we are doing the classic trade-off between time and space. I am decreasing time, but I am going to increase space, right? So how do I ensure that the space complexity, right, is not exceeding? That's something which we'll look at it. But then this is a trade-off, right? So sometimes when the time complexity is very, very high, I increase the space in order to reduce the time complexity, and that is what dynamic programming is, and that is where dynamic programming helps. Now, naturally, right, Fibonacci series is a very theoretical question. We will solve some interesting questions also. But before that, I would like you to understand what are the kind of problems, right, where dynamic programming is applied, and also, right, there are two techniques in dynamic programming. One is called as memoization, not memorization. It is memoization. The second technique is called as tabulation. The second technique is tabulation. We'll also look at what is memoization and tabulation, two methods or techniques in dynamic programming. And we will also look at how, right, you can use dynamic programming, right, in multiple ways, right? So in multiple problems, how to think in dynamic programming paradigm. So that is something which we'll be looking at. Now let's go ahead and solve this Fibonacci series problem itself using, let's solve this Fibonacci series problem itself. I'm going to erase these things so that you can have some space here. So I'm going to solve the Fibonacci series problem using the dynamic programming technique so that we will reduce the time complexity. So how do I do that? Like I said, there are two ways of doing it. Let's first do the easiest way where we are optimizing the recursion. How do I optimize the recursion? So I'm going to say that, hey, fib of n, right, is equal to, now if I'm going to initiate something called as fib array, right? So now let's say I'm going to initiate this array into 100 values, right? So I will say, hey, this is going to be -1, -1, -1, etc. for 100, right? So now which means that I can calculate the Fibonacci value till 100 using this particular function. So I am going to say, right, if n is equal to 0 or n is equal to 1, I can return n. That's the same thing. Now I also say that if fib of n not equal to, fib array of n not equal to -1, then return fib array of n. So what am I saying? Hey, I am going to check for this particular value, right, the n value in the array, and if that is not equal to -1, then I am going to return the value saved in the array. If it is equal to -1, which means that the value is not set, then I am going to return the function which is fib of n-1 plus fib of n-2. Are you guys following this? So what have we done? So can you see the difference between these two? Here we were repeatedly calling this function, whereas here I am saying that, hey, if I already have the answer to it, why am I calling it again and again? If I have the answer to it, right, then I am going to save it in an array, and then if the array value is already set, then I am going to return the array value itself, right? So this is called as dynamic programming memoization technique. So what is this memoization? The word memoization, right, you would have heard of this word memo, right? What is memo? Memo is something to be remembered. Memo is something to be remembered. So what am I saying? Hey, instead of calculating this again and again, if I calculate one value, for example, while I am solving this problem, I am calculating one value, then instead of letting go of that value, save it in an array. I am going to explain again, don't worry about it. I am going to say that save it in one place in an array, which means that, for example, what will be the first two values of the array? I will call it 0 and 1, and all the other values will be -1. So if I look at the index of this array, 0, 1, 2, 3, 4, 5, etc. So let's say what will happen for fib of 5. What will happen for fib of 5? Let's do that again. What will happen for fib of 5 when I try to calculate fib of 5? Right? So fib of 5 is going to call two functions, which is fib of 4 and fib of 3, right? But before that, think about it. First, when I ask for fib of 5, what is it going to do? I am going to check in the fib array. Fib array is going to be, let's say the array has 6 values only. I have 0, 1, -1, -1, -1, -1. I am using -1 just to indicate that it is not set. So don't worry about it, you can use any value here, as long as, so in certain programming languages, right, you can just not set anything also, don't call it anything. For example, in JavaScript you don't need to set anything, right? But in certain languages like C or C++, it is very well defined, so it is very strict, right? So in that case, you might want to define some value here, right, just so that you are explicitly calling it out. So I am saying that when I am asking for fib of 5, what is happening here is I am checking for, this is fib array of 0, fib array of 1, fib array of 2, fib array of 3, fib array of 4, fib array of 5. Actually you can get rid of this also, right? So now let's check for fib of 5. So what is happening for fib of 5? When the function is called, what is the first thing I am going to check? I am going to check if fib array of n is not equal to -1. What is fib array of n? Right, fib array of n is fib array of 5. Fib array of 5 is this value. I am talking about fib array is nothing but a Fibonacci array, a data structure which I am using to save these values. So when I check for fib array of 5, which is equal to minus 1 here, so if it is, because this is not equal to minus 1 only, this condition will execute. Because it is equal to minus 1, this condition will skip, right? So when it skips, I am going to return two more functions, fib array of n minus 1 and fib array of n minus 2, which is nothing but fib of 4 and fib of 3. I am returning fib of n minus 1 and fib of n minus 2, which is fib of 4 and fib of 3. Right? So now I am going to check for fib of 4. So the function will be called, fib of 4 is called. Now fib array of 4, which is nothing but again minus 1. So this will not execute. Right? So this will not return the value here. This condition will skip and this function will call two more functions, which is fib of 3 and fib of 2. Are you guys following this? So far, are you guys following this? Right? So basically, right, we are saying that fib of 5 will call fib of 4 and fib of 3. Fib of 4 will in turn call fib of 3 and fib of 2, because so far we have not calculated anything. Right? So now let's start from fib of 3 here, right? Just for space. So fib of 3 is again going to call fib of 2 and fib of 1. Now we will know for when I call fib of 1, it will return the value of 1 itself. When it calls fib of 2, again I check for fib array of 2, because it is equal to minus 1, this condition will skip and it is going to again call fib of 1 and fib of 0. Right? So when I call fib of 1 and fib of 0, right, I can see that the values are there. Fib array of 1 and fib array of 0 is there. So 0 and 1 will be returned. So first time the entire function executes. Don't worry if you don't understand. I'm going to clear the screen. I'm going to explain it again. Right? Basically what we are saying is fib of 5. This is fib array. Right? We are calling it as 0, 1, minus 1, minus 1, minus 1, minus 1. Let's assume that there are only 6 values in the array. Right? So what is the index? I'll call this index. I'm going to call it 0, 1, 2, 3, 4, 5. So when I say fib array of 3, it is going to return minus 1 now, for example. Right? So now in the tree, what is going to happen? Let's look at it. Right? I am going to call fib of 5. When fib of 5 happens, the first thing I am going to check for is the fib array of 5 set. Right? Is the fib array of 5 set here? It is not set. So we are calling the condition will fail, and the function will call the recursive function again. The recursive part of the function will execute. So fib of 4 and fib of 3 will be called. Then when I will call fib of 4 and fib of 3. Right? Let's take fib of 3 first. Now fib of 3 is going to call fib of 2 and fib of 1, and fib of 1 is in turn going to call. It is set, right? When I check for fib of 1, it is going to first check for fib array of 1. So this will be 1. So the value returned will be 1 here. Right? Now this will not call anything further. So it is a dead end. Right? Now fib of 2 is going to call fib of 1 and fib of 0. Right? I will check for fib array of 1, which is nothing but 1, and fib array of 0, which is nothing but 0. So fib of 2 will be returned as fib 1 plus 0 or 1. Fib of 2 is returned as 1. So when it is returned, right, when fib of 2 is returned, what I am going to do is, I am going to write the function here for your, the algorithm here for your reference. I am going to say that fib of n, the first condition says, if fib array of n not equal to minus 1, then I am going to say return fib array of n. Otherwise, I am going to say return fib of n minus 1 plus fib of n minus 2. Now this is again a recursive function. The one thing which we need to do is, before returning this recursive function, you need to save it in a value. So what are you going to do? Instead of returning it directly, I am going to say fib of n is equal to fib of n minus 1 into fib of n minus 2, and I am going to return fib of n here. Are you guys following this? Right? So basically, right, what will happen here? So it is fib array of n. Fib array of n is equal to, I am calling it out as fib of n and fib array of n just to differentiate, right, for you guys. Right? Basically what we are saying here is, when I calculate a value, I am going to save that value in the array. So when I calculate fib of 2 here, right, so when I calculate fib of 2 as 1, this is the first time when the dynamic programming kicks in. Till this point in time, it is going to be at a similar position to the simple recursive function, right? But at this point in time, the dynamic programming kicks in. So what are we saying here? Fib of 2, the moment the value 1 is calculated, I am updating it in the array. So this will become 1. I am going to update it. So when the next time fib of 2 is called, for example, when I say fib of 3 and fib of 2, here I am not going to enter into the recursive call itself, because what am I doing? I am doing a condition check, right? I am checking for fib array of 2 here. When I do the condition check, is it not equal to -1? Yes, it is not equal to -1. So it is going to get updated in the array. Are you guys following this? It is already updated in the array. So I am just going to fetch it from the array, and then I am going to return it to the function. So the recursive tree is actually going to be very simplified. The recursive tree is going to look like this, right? Instead of saying fib of 5, I am going to draw the recursive trees, right, for both cases. So this is how it is going to look like, the recursive trees for the cases. But here it is going to look like this. Fib of 5 is going to call fib of 4 and fib of 3. Now fib of 4 will again call fib of 3 and fib of 2. Fib of 3 will call fib of 2 and fib of 1. Fib of 2 will call fib of 1 and fib of 0. Can you guys see the difference between these two? The moment you plot it, right, so you can see that the number of times the tree is expanding is exponential here, whereas it almost becomes linear here. It is actually linear here. It is not exponential. This becomes linear. So it is fairly simple, right? So you can look at how you are converting exponential time complexity to linear time complexity. So whatever we did it here is called dynamic programming, and the method is called as memoization. So what are we saying? Hey, memoization, and the difference between memoization and tabulation is again top down, right? So it uses recursion, whereas the tabulation method usually is bottom up and it uses iteration. We will also look at the tabulation method shortly. So memoization is recursion and tabulation usually uses iteration, right, in dynamic programming. So dynamic programming is not necessarily restricted only to recursion programs, right? It can also be used in iterative programming, right? So basically whenever you need to solve the subproblem's solution multiple times, that is when you will look at saving the answer to the subproblem in a data structure. In this case we saved it in a array, right? So this is called as dynamic programming. So this is an algorithm design paradigm. So we can keep, right, applying this in multiple programs, right? What are the kind of problems where we can use it? We can use it in maximization or minimization problems. We can use it in decision making, yes or no problems, right? So we can use it in counting, so permutation problems basically, where I am counting the number of ways in which you can do something, count some problems, right? There are many situations where you can apply this dynamic programming techniques. It is an algorithm design paradigm. So we looked at memoization now. What is memoization? I start from the answer itself, right? I start from the fib 5, right? And then I am going to talk about, hey, to solve fib 5, what are the subproblems? Fib 4 and fib 3. I am going to save, if fib 4 was already calculated, the moment I calculate fib 4, I am going to save it in an array. So this is called as memoization, where I am going top down, right? So let's also look at another technique, which is tabulation technique. So what is tabulation technique? I said it is a iterative way of solving dynamic programming problems, right? So in tabulation technique, it is fairly simple. I am going to set an array and I am going to call it fib array of 0 is equal to 0, fib array of 1 is equal to 1. Then I am going to initiate a for loop where I am going to say for I is equal to 2 to n. I am going to say fib array of n is equal to fib array of n minus 1 plus fib array of n minus 2. Now I am going to say return outside of this I am going to say return fib array of n. So this is the iterative way of solving this, right? So basically what I am saying is, right, now what is this happening? So there is an array. Now I am saying this is 0 and 1, right? And there could be any values in the subsequent places, but I am constructing it from the bottom. I am constructing it from the first two values, right? So what are we saying here? We are saying that, hey, when I is equal to 2, it is iterative, right? It is using a for loop. When I is equal to 2, what is going to happen? So this is going to be, sorry, this is I. This is I minus 1 and I minus 2. So when I is equal to 2, it will say fib array of 2 is equal to fib array of 1, which is 1, and fib array of 0, which is 0. So I will update the value 1 here, right? When I is equal to 2, I will update the value 1 here. When I is equal to 3, I am going to check this. So it says fib array of 2 plus fib array of 1, which is nothing but these two values. I am going to update 2 here. So then it is going to be 2 plus 1. When I is equal to 4, it is going to update 2 plus 1, 3 here. So when I is equal to 5, which is the Fibonacci number of fib of 5, it is going to return 3 plus 2 or 5 here. So this is called as tabulation technique. So do you understand the difference between memoization and tabulation? Right. So memoization is where, right, you are going backwards, right? So if I have to calculate fib of 5, I am going to keep solving recursively, and then wherever I am finding an answer, I am going to save it in a data structure. In tabulation, I am starting from the first two steps here because it is Fibonacci series, right? So it is going to come this way. Now there are a couple of questions which are asked here, right? What is the difference between tabulation and memoization? When should I use memoization and when should I use tabulation, right? So there are pros and cons for tabulation and memoization. I hope you understood tabulation and memoization well. So I am going to explain to you. For example, right, in both the cases, whatever we discussed, the answer, right, the time complexity is O of n, right, and the space complexity is also O of n. So if you use brute force, right, in recursion, for example, it is not going to give you the O of n complexity, right? This is called as a dynamic programming technique. So I am also answering a few questions, and I will also take questions towards the end. Now, what is the difference between tabulation and memoization, right? Or I will call it iteration and recursion in dynamic programming, right? So tabulation is what usually is preferred in competitive coding, primarily because in tabulation you are constructing things from scratch, right? And hence in majority of the cases, the questions which you will encounter, the problem will require that all the subproblems are calculated before I can arrive at the problem. For example, if you look at Fibonacci numbers itself, right, I can't really solve fib of 5 or fib of 4 without solving fib of 2. So and hence it has to be anyways linearly solved, right? So in those cases, tabulation is actually efficient, right? There are certain places where memoization is efficient. That is when there is for example, right, there is an intermediate subproblem for which I am eliminating it, right? So let's say the tree is like this. I need to calculate a function of 10. Like this is not Fibonacci series, right? It's not fib, right? It's not Fibonacci series. Let's say I want to calculate the 10th node, right? And for 10th node, I need to know these two nodes, right? Which is 9th node and 8th node. Now I just need to know the maximum of these two things, or somehow I am able to find that 8th node is not going to give me the answer. So then the entire recursive tree behind this 8th node can be eliminated in some problems, not in Fibonacci series. In some problems, this entire tree can be eliminated, and only in those cases memoization is preferred. But usually, right, those cases can be handled in tabulation also. So tabulation is usually preferred in competitive coding. But if you are looking at solving interview problems, whichever way you prefer it, it's actually how you prefer it, right? So when all things being the same, iteration is preferred because it is cleaner, right? It is simpler to understand. Recursion is slightly more complicated to understand, and recursion also builds the stack, right, which we spoke about, which builds the call stack, right? That is something which we already spoke about, right? So this is the difference between tabulation and memoization in dynamic programming. So we looked at a Fibonacci series problem. Now tabulation in Fibonacci series also offers a more elegant way of solving it. So we said that time complexity in the tabulative iterative method was O of n, and space complexity was also O of n. So we will anyways look at tabulation again now. I am going to write tabulation again. I am going to say that fib array of 0 is equal to 0, fib array of 1 is equal to 1. Now I am going to say that for I is equal to 2 to I is equal to n, fib array of I is equal to fib array of I minus 1 plus fib array of I minus 2. But if you draw the recursion tree, you can see that, hey, right, I don't need to solve this way, because every time, right, I am building the recursion tree fib of 4 and fib of 3, I just need to know only the previous two values, right? For example, the moment I have calculated fib of 4, fib of 2 becomes useless to me, isn't it, right? So fib of 2 is no longer needed, because, right, the moment I have calculated fib of 4, I can calculate fib of 4 only if I know fib of 3, and for calculating fib of 5, I just need fib of 4 and fib of 3. So what you can actually do is, instead of having an array, you can just have two variables, right? You can call it first variable is equal to 0 and second variable is equal to 1. Instead of having these arrays, right, you can even more optimize for space. I can say that for I is equal to 0, sorry, I is equal to 2 to I is equal to n, what am I going to do? I am going to say that, hey, the value, right, so the value first variable, or the second variable is equal to second variable plus first variable, which means that I am going to say that, hey, I am resetting the value of the second variable. Before that, naturally I should have reset the value of the, sorry, I think I may need one more variable to solve it here, but it is nothing but swapping values, right? So what am I doing here? I have first variable, I have second variable, I have two values here. Now I am calculating a new variable here. So in this I am going to save this plus this, right? So the third variable, I can call it the third variable, for example. Third variable is equal to second variable plus first variable, and then I am going to call, right, second variable, sorry, one second. So this is third variable, right, where I am going to save the sum of these two numbers. So 0 and 1, the third variable I am going to save this, and then I am going to discard this, which means that I am going to shift it, right? So whatever is the third variable, I am going to shift it to the second variable, and whatever is the second variable value, I am going to shift it to the first variable, which means that I am going to say that, hey, second variable, first variable is equal to second variable. That is something which I will do, and second variable is equal to third variable. That's it. Are you guys following this? Basically I am swapping these values. So for I is equal to 2 to I is equal to n, I am saying that I have a new variable which is the sum of previous two values, and then I am going to say that, hey, this is no longer needed, so I am going to replace this with this, and I am going to replace this with this, right? So when I do that, naturally, right, I am shifting so I am reducing the space complexity from O of n to a constant space, or O of 1. So that is the benefit of, right, the iterative way of solving dynamic programming, because it is cleaner and it also gives you a thought process. We can actually check, right, if we are able to, right, save things, right? We can check how we can eliminate space, because we are able to visualize space. The time complexity and space complexity is fairly straightforward in the iterative methods, right? So this is the long and short of dynamic programming. Now we are going to look at some problems, right, to do dynamic programming. Let's do some problems here. So let's take some famous problems, right? The first problem which I am going to take is a staircase problem. So what is the staircase problem? Staircase problem is fairly simple, right, in that sense that basically what we are saying is, hey, I have a staircase containing of n steps, Now I am at step 0 and I can take one step or two steps at a time, right? At one time I can either take one step or two steps. Now how do I, in how many ways can I reach the top, right? For example, let's call it step 0. This is step 1, step 2, step 3, step 4. So in how many ways can I reach the top? I can go one step here and then maybe jump two steps here and then take one step and reach here. This is one way, right? Like that, how many ways are there is going to be the question. Now, how is this relevant to dynamic programming? So I will tell you how. See, so far we looked at what is dynamic programming and we solved Fibonacci series using dynamic programming. Now I am going to try and tell you how people think when they apply dynamic programming to a problem, right? So how do people think when they apply dynamic programming to a problem? First they will think, okay, so they will think something called as state, right? So what is the state? That is probably the end result of the problem. So what is the end result of the problem? It is the total number of ways, right, at a particular step, right? Which means that I can call it number of ways, right, or number of ways, right? Could be the, so I am taking elaborate variable name so that you understand. So number of ways is going to be the at a particular step, at kth step is going to be the state, right? So to reach kth step, how many ways are there is going to be the state, right? So that is the first thing which you need to determine. So what is this, right? In a yes or no problem, it is usually a Boolean value, right? It is yes or no, right, at a particular point. So in this case, it will be an integer, right? So you need to. So in some cases, it could be even matrices, right? It could have 2 dimensions. It could be an integer matrix, right? So integer array, integer matrix. There are many ways of understanding this. What you need to worry about is what is the state, right, which you need to figure out. So in this case, it is going to be the number of ways at kth step, right? So now. To calculate the kth step, right, all the other things do not matter, but how do I reach kth step, right? I can reach kth step from, right, so the k minus 1 step or k minus 2nd step, right? If I have to reach 4, right, I need to reach here 4 from step 3 or step 2. I cannot reach the step otherwise, right? So I cannot reach the step 4 from step 1, for example, right? So if I know the number of ways in which somebody has reached step 3 and number of ways in which somebody has reached step 2, I just need to add these 2 ways and then I will get the number of ways in which somebody can reach step 4. Are you following this? So let's say steps or number of ways, right? Ways, right, at a particular step, right, is equal to ways of step minus 1 plus ways of step minus 2. Are you guys following this? Right, it is a fairly simple problem. It is very, very similar to the Fibonacci series problem, except that at 0th step I am going to take 1, right, because I will already assume that. So to reach step 1, right, I will reach from here, right, so which means that there is already one way of reaching, right, step 1, right, so this should be taken as 1. So we are talking about this is nothing but a Fibonacci series problem where the first value is going to be 1, the second value is going to be 1, and then you can have an array, right, so you can have an array like this and then you can keep building that array. So this is 0, this is 1, so 2, 3, 4, 5. So if I have to calculate the 5th one, it is going to be 1 plus 1 which is 2, 1 plus 2 which is 3, 2 plus 3 which is 5, 3 plus 5 which is 8. So I am going to get the answer for the number of ways at kth step by actually following this method, which is very similar to the Fibonacci series problem. So that is how you, this is again a dynamic programming problem because, right, you should implement it. So how do you implement it matters, right? So you can either implement it using memoization or you can implement it using tabulation, but it is still going to be a dynamic programming problem. So that is something which you need to understand. So staircase is a famous problem, right? So there are many other modifications of the staircase problem which you might encounter. For example, they will say that, hey, right, what if the steps is 3, right? The number of steps, you can take at most 3 steps could be the problem. You can also say at most, right, you can have 3 jumps. Right. So, for example, this is 1 jump, 2 jump and 3 jump, right? So like that at most you can have only 3 jumps, right? So there are many modifications to the staircase problem and depending on that the state is going to change, right? So I will talk about a 2-dimensional state in a different problem where it is easier for you to understand. I do not want to confuse you by taking a staircase problem and trying to explain how, for example, this will involve, right, when I say at most 3 jumps, right, then if you look at the state, right, what will the state be? If I look at most n number of jumps, the state will matter here because, right, it is not only going to be the number of ways, right, it's not only going to be the number of ways, it's also going to be the jumps, right? It's not just going to be the integer so far, it's also going to be jumps. It's a variable, isn't it? It's not the step only, it's not just the step, it is also the jumps also will matter. For example, when to reach here, before this thing, right here, how many jumps has already been made? Here, how many jumps has already been there will matter. For example, if I am running out of jumps here, I can just make only, I can straight away jump here, I can't make 2 jumps, right? Because I have already run out of the jumps. At most I can make k jumps, right? So that is so anyways, this is something which you don't need to understand. So one suggestion which I have is, if you are getting started, and this is anyways targeted towards beginner to intermediate programmers, that if you are getting started, I would suggest do the easy problems first, get very familiar with dynamic programming before you can try out your hands at difficult problems. We'll anyways take a 2-dimensional problem to solve it also. So this is a staircase problem where you can again apply dynamic programming. Now these are all again straightforward, right? It is very similar to Fibonacci series where, right, the whole thing was quite linear. So let's take one more problem, right, which is house robber problem, right? So let's take a house robber problem. So how do I solve this house robber problem? So what is a house robber problem? So let's take so we solved the staircase problem. Let's take the house robber problem now. So what is this house robber problem? It is a fairly simple problem, right? You have a block of houses to rob, right? So you are a robber and you have identified that, hey, you have a block of houses to rob, right? But then there is a security system which says that if you rob consecutive houses, you are going to get caught. But you are also aware of how much value, right, each houses have, right? So for example, let's say this is rupees 5. This house's value is rupees 5 lakh, right? Let's call it lakhs. Right, this house's value is 10 lakh, and this house's value is 3 lakh, and this is 2 lakh, this is 5 lakh, and this is going to be 1 lakh, right? So now what are the houses which you will rob? Now constraint which is given here is I can't rob consecutive houses, right? If I rob consecutive houses, then the alarm is going to get triggered. Now how do I solve this problem, right? Again, the same thing, right? In dynamic programming, right? Basically, all I am saying is to figure out, to reach here, I need to solve sub problems, right? Instead of, so for example, to get the optimal solution till this point, I need to know what is the optimal solution till this point. I need to know what is the optimal solution till this point. What is the optimal solution till this point? What is the optimal solution till this point? What is the optimal solution till this point, and so on. So that is how you build the states, right? So once you build the states, right, it is very easy for you to calculate the answer to this. Now how do I go about solving this problem? Basically, I need to first break the problem into pieces, right? So what is the choice which I have to make? At each stage, I have to make a choice on, hey, should I rob this house or no, right? So this is a simple choice which I need to make. Now to, let's say, how I will decide whether I will rob this house or not, right? So to decide on whether I will rob this house or not, I need to maximize the total stolen value right here, which means that I need to know, hey, to rob this house, if I am robbing this house, I cannot rob this house, right? If I get robbed this house, it is automatically eliminated. I cannot rob this house if I have already robbed this house, which means that, okay, so till this, if I have robbed, whatever is the value, max value until this point, right? I also have max value until this point, right? So now I need to compare the max value until this point to the max value until this point plus the value here. For example, are you guys following this? Right? So it is a recursive algorithm which we are building, right? So basically what we are saying is, hey, to know whether I need to make a decision on whether I need to rob this house or not, right? So now till this point, if this house is robbed, whatever is the max profit I have made, right? And if this house is robbed, whatever is the max profit I have made so far, now I need to compare this profit, this max value with this max value plus the current house's value also, because right, by maximizing or by robbing this house, I am eliminating or foregoing the option of robbing the last house, right? So it is again something which is very familiar pattern, right, which is already familiar now. So it is like a Fibonacci series. So if I have to build a recurrence relation here, what I am going to say is, hey, I am going to say that f of I, which is to decide on whether I am robbing this house or not, I am going to say it is going to be max of f of I minus 2, which is till this point whatever is the function value, right, with the function return value, the max, the same function's return value. What is the function returning? It is the max profit, right? Max profit which the robber makes is what the function is returning. So I am going to say that function max profit at I is nothing but maximum of max profit at I minus 2 plus value of I, right, which is here value of this house, right? Or right, the other thing which I can get is either I can max profit of until this, I can rob this house and then rob this house, or I can rob only this house because I can't rob consecutive houses, right? So I can write it as f of I minus 1. So I will compare these two. So in Fibonacci series it was very straightforward, right? So you just kept adding the two values. Here you need to add the value in a specific node also, right? So which means that this is the recurrence relation. Now again, right, there are many ways of implementing it, right? So this is a recursive way of implementing it. How do I implement it in a bottom up implementation, right? So how do I implement it in the other way around? So I will say that, hey, right, I will have a variable. Let's say I have a variable which has a as 0, and I will have a variable which is b as 0. Naturally, I will have profit number of houses here, right? So this is going to be the function profit. If I rob n houses, I am going to say a is equal to 0, I am going to say b is equal to 0, and then I am going to say that for I is equal to 1 to I is equal to n, I am going to say that a is equal to b and b is equal to max of b comma a plus value. Are you guys following this here? So what am I saying here? I am saying that simultaneously, so this has to be implemented simultaneously, where I am saying that, hey, this is house 1, this is house 2, 3, 4, 5, let's say 5 houses, and I will take the values also. 5, 10, 3, 2, 5, okay, 5, 10, 3, 2, 5. For easy sake, right, we can just take these two things. So what will be the max value? Actually, I need to rob this and this, right, the house 2 and house 5. So what is happening here is, I am going to say that I am resetting these variables into 0. When I is equal to 1, which is when the house value is 1, I am going to just say that, hey, I need to handle this condition, right, where b value is anyway 0, so b value is 0, right, or a value is also 0 plus 5. So should I rob this house or should I not rob this house? Because the previous value is 0, I should rob this house, right? So if I have only one house, will I rob it or will I not rob it? I will rob it, and hence the answer to this till this point, right, it is 5. Now what is happening here? The first value, right, so a value is becoming 0, b value is becoming 5, right? So now this I need to make a decision with if I have only two houses. If I have only two houses, what will happen? So I is equal to 2. For I is equal to 2, the iterative process continues for I is equal to 2. If I have only two houses, how will I decide, hey, should I rob this house or should I rob this house, right? So b is equal to 5, so I need to calculate the maximum of 5 into a plus value, so 0 plus 10, right? So naturally I need to rob this house, right? So because the decision will be, so if this is higher, right, so if the other value b is equal to 5, so I am comparing 5 and the maximum value between 5 and 0 plus 10, which will give me 10. So because this is getting ticked, I need to rob this house. I will make a decision of robbing this house, which means that my profit so far is, I couldn't have robbed this house, my profit so far is nothing but the maximum, which is 10. So what happens when I is equal to 3? So this is I is equal to 2. So for I is equal to 1, a was 0 and b became, after I is equal to 1 iteration was executed, a was 0 and b became 5. After I is equal to 2 got executed, b was 0, sorry, b was 5 and A is 5 and B became 10. Are you guys following this now? It is a very classy problem where I is equal to 3. When I is equal to 3, when I am considering the third house into the equation, I am saying that the universe has only these three houses. I don't care about the 5 houses. When the universe has only these 3 houses, how am I going to go about it? I am going to say that, hey, now the swapping will happen. A will become B, so A will become 10. Now B is nothing but max of, right? What is the max of, so which is 10? I need to consider 10, and then I need to consider A plus 5 plus 3, the previous A, which is 5 plus 3 in this case, right? So 5 plus 3, which is the maximum. 8 is the 8, 10, which is the maximum. 10 is the maximum, right? So I need to consider these two things. So which means that, so the profit till this point is again going to be only 10. The best choice is robbing this house. Don't rob, right, this house and this house, right? So don't rob is the decision here. So the best profit so far is 10. So it will keep going like that, and finally I will calculate the profit as 15 when I rob the fifth house. So this is a dynamic programming implementation, right? So house robber problem is a famous problem, right? It is asked in a lot of interviews. The staircase problem is a famous problem, right? It is, you will not believe it. These are questions which are asked in Amazon, Google, etc. So it is important for you to understand dynamic programming as a method, right? So once you understand the method, it is actually fairly simple, right? It is simple for you to figure out. Yeah. So now let's go to one more problem. So we are going to one more problem here, which is another classic problem. Now we are going to introduce something around two-dimensional dynamic programming, right? So so far we were looking at data structures which were quite linear, right? So we said there was an array maximum, or we were talking about how, right, you can actually do it in space complexity of 1 itself, right? So now we are going to talk about a problem which is a minimum path sum problem. So what is a minimum path sum problem? It's a fairly simple problem, right? A minimum path sum is, let's say I have a grid. I am going to fill some numbers in this grid. So let's put some random numbers here, right? So the row values and column values also I will indicate so that you will understand it. So it is 0, 1, 2, 3, 0, 1, 2, 3. I am going to fill this grid, which is as 1, 4, let's say 3, 1, 5, 3, 8, 2, 7, 1, 9, 3, 8, 6, 3, 2. Let's put it, right. So now we are going to talk about, right, the minimum path sum or maximum path sum, right. So let's say I am going to travel from this point 0, 0 to 3, 3. So I am going to travel from the leftmost grid to the bottom right. So I am going to travel from left top to bottom right. Now, if to travel there, I need to ensure that the path gives me the least cost, right? So what is the path which gives me the least cost? For example, I go like this, right? 1, 4, 3, 1, 2, 3, 2. So it is 4, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 16 is the least cost, right? So how did we spot it? We visually spotted it, right? So we are talking about visually spotting how this thing, but unfortunately, right, when there are larger grids and in algorithms, right, algorithms don't have the power of visually spotting it. So you need a systematic way of solving this problem. How do you systematically solve this problem? Again, you use dynamic programming. Again, like I said, it can be solved recursively or using tabulation. Tabulation method is usually the easiest method to solve. So now how do I imagine the state? I will imagine the state as, what is the minimum sum at a row column grid. So that is the state, right? So I said we need to think about the state. Now I need to think about at each point, what is that I want to calculate? I want to calculate the minimum sum, which means that minimum sum of a specific row and column is going to be the state, right, which I need to be worried about, right? So now how do I calculate the state for each value? Now it is fairly simple. If you look at it, to calculate the state for this, right, from where can I come here? So the problem also, the constraint is usually, right, this is a common problem. The constraint is I can either move to the right or bottom. I can't move back, right? So then it becomes a circular problem, right? I can keep going back and forth, right? So I need to either move right or down. I can move right or down. I can't go left or up, right? Is the constraint which we also have, right? So how do we solve this problem? To reach here, I could have come from here or I could have come from here. Now I need to know what is the minimum sum at this point and what is the minimum sum at this point. I need to just figure out what is the minimum of these two and then add this value to arrive at the cost for this. Are you guys following this? Right, I am going to draw a table. So we spoke about tabulation, right? So this is a table. I am going to draw a table. This is why it's called as tabulation. Basically, you are tabulating the state, right? So now I am going to say that 0, 0, 1, 2, 3, 1, 2, 3. Now let's say that there is a 1 cross 1 grid. How do I reach here? Naturally, the cost of this is going to be 1, right? How do I reach here? Now I need to reach from here only. So the cost of this is going to be 1 plus 4 or 5. The cost of this is going to be, I can reach here only from here. So it is going to be 5 plus 3, which is going to be 8. The cost of this is going to be 8 plus 1, which is going to be 9. So far so good. So here also you can draw it like this. So it is going to be 1 plus 5, which is 6. 6 plus 7, which is 13. 13 plus 8, which is 21. Now how do I calculate it for here, right? So that is where the tricky part comes, right? You need to think of it as whether it is a minimization problem or a maximization problem. Here it is a minimization problem. Now how do we come here in the minimization problem? Basically we are talking about, hey, I could have come here from this 6 or from this 5. Which is more efficient, to come from 6 or come from 5? So I need to come from 5. So I am saying that, hey, I am going to take the minimum of min sum of row minus 1 or column, comma, min sum of row column minus 1. So what is this, right? This is I am reducing it by one column. This is I am reducing it by one row. So I need to calculate, right, this using this. Not only that, I also need to, after calculating what is the minimum, I need to add the value at the row column. So what is the value at the row column? This is the value, right? This is the exact value at row column. So I am taking this 5. What is the minimum of 5 and 6? 5. And then what is the value at this space? It is 3. So I am going to say it is 5 plus 3, which is going to be 8. Right? So now I can keep filling, right? So now again 13 and 8, what is the minimum value? 8. I add 1 to it. So this is going to be 9. So now 21 and 9, I have 9 is the minimum value. So the value at that place is 6. So I am adding 15 here. Now here, how do I fill this? 8, 8, both of them. So I can, so now there are two paths, right? I can either take this path. For example, we spotted visually this path, but this is also one of the path, right, which we could have traveled, but subsequently, so for example, 1, 4, 3, 1, 6, 3, 2. How much is it coming to? 5, 8, 9, 15, 18, 20. Okay, this anyways a path is eliminated. But at this point in time, till I reach this point, I can take any of these things, right? So for this, I can actually go like this, sorry, 1, 4, 3, this is the path, yes. So I can take this path, 1, 4, 3, 8, 2 and whatever is the numbers here, right. So the numbers are actually 3 and 2, right. So now I can, how do I calculate the value here? 8 and 8, I can take any of these values because minimum of 8 and 8 is going to be 8. And here the value was 8. So I am adding 8 and 8 and I am saying it is 16. Right? So how do I calculate it here? 9 and 16, the minimum value is 9. The value here is 2. So I am filling it as 11. So here 16 and 9, the value minimum value is 9. 9 plus 9 is 18. So minimum value is 11. 11 plus 3 is 14. 15 and 18, the minimum value is 15. 15 plus 3 is 18. 18 and 14, the minimum value is 14. The last value here is 2. So I have 16 here. So I just simply return the min sum at row and column will be the answer, which I will be returning as a function. Are you guys following this here? It's fairly simple, right? I will again, right, go through this, right, so that you will understand this clearly. So this is the last problem, right? I would want you guys to go ahead and implement it in whichever is your favorite programming language. Now I am going to implement this again, right, so that you will understand this easily. So what are we saying here? I am just saying that, hey, I will draw the grid again. I am just trying to help you understand this better. So basically what we are saying is there is a values grid, right? So this is the values grid. I am drawing the values grid. I am again going to help you understand this better. The values grid is 1 4 3 1 5 3 8 2 7 1 9 3 8 6 3 2. So this is the values grid. Now we are going to figure out what is the path which I need to take, which will give me the min sum, right? So minimum sum, right? So it could be a maximization problem also. So what I am saying is, in dynamic programming, right, to calculate this path, so to calculate the min sum till this, I need the min sum till this and min sum till this. If I have the min sum till this and min sum till this, the value here is going to be minimum of min sum until here and min sum until here. So let me call it A and let me call it B. So I am going to say it's minimum of A and B plus the value at the node, the value itself, right? Which means that if whatever is the minimum which I calculate, right? So to calculate this, I need minimum until this and minimum until this. It is a recursive function, right? It's like recursion. It's a repeating process. So to calculate the minimum value at this, I need the minimum at this and minimum at this, right? So what we are doing is we are making a table. So all these things you will do it programmatically, right? So you will create a integer array which is two-dimensional, right? So this is a integer row column array, right? So each of this is going to be an integer, and you will start. It is an array, right? So this entire thing will be an array. It will be an array of arrays, right? Or a list, or whichever programming language you use, right? This will be something like, right? Just for your visualization purpose, the data structure is going to be like this, right? It will have 4 arrays, right? One array, one full array, and then there will be these arrays, right? This is how an array of this will look like, right? But however, for visualization purposes, I am making it like a table. So 0 1 2 3 0 1 2 3. So what is it, right? So how do I calculate the minimum sum at the lowest node? So it is going to be, if I take this path, I am going to end up with 1 here anyway, right? Now the minimum sum at here is going to be 1 plus 4. I need to add these two values. So it is going to be 5. Now I need to add 5 and 3 to get the minimum value here, which is 8. Then I need to add 8 and 1 here to get the minimum value, which is 9. Because it is straightforward in the edges, right? So here it is going to be 6 and 13 and 21. So far it is fairly straightforward. Now when I calculate it for a two-dimensional element is when the tricky part comes. So what are we saying here? So we can see 6 and 5. So what is the minimum sum? So I can reach this point from here or here, because it is a grid problem, right? I am traversing the grid. So I can traverse the grid from here or here, because the problem clearly says that I can go right or I can go down. So I could have reached here only from here or here. So I need to take the minimum cost so far, because we are minimizing. If it is maximizing, I would have taken the maximum. So to fill this point in the table, I need to take this 5 and then I need to add it with the value at that point, which is 3, and then I am going to populate it as 8. Yes. So once I know that, I will find the final answer, right? So whatever is the final answer which we got, it was 16, right? So 16 was the final answer. I can populate the grid and I can get the final answer. So that's broadly it, folks, right? This is dynamic programming. Before, right, I will take questions now, right? I know that I can see a lot of questions in the chat. Before going into the questions, I would like to reiterate some things here. One is subscribe to the channel if you want more such video lectures or live sessions. That is one. Second is we are also adding a playground link to the description, which means that I know that there is not, as in I am giving you algorithms here, but you still need to implement it either in your interviews or wherever you go. So it is important for you to solve this in a programming, so write it as a program in whichever programming language you like. So we have created a playground with some practice questions in dynamic programming. So I would strongly recommend that you guys go and implement that in the playground. So that is broadly it. Now I will so subscribe to the channel and see the playground link in the description. The other thing which I would also urge you to do is set the reminder for the subsequent session, which is going to happen tomorrow, guys. Right? So that is broadly it. If you have any questions, you can type now. Right? I will take some questions now. Yeah, so you got your wish, guys, right? So the session was supposed to be for half an hour, but given you guys requested, we have extended the session to 1 hour based on what you guys wanted. If you guys have any questions on whatever we have covered so far, right, I will take it. Thank you so much, guys. Right, if there are any questions, you can leave it as a comment, right, and we will try to answer it. And looking forward to meet you tomorrow. Thank you so much, guys.